Now, I have the pleasure to introduce a very good old colleague of mine, Konstantin Kulterer. He works for many, many years, 15 years, at the Austrian Energy Agency in Vienna, Austria. He is an expert in all things that have to do with energy efficiency. He has studied economics, environmental technology, and management. And we've had collaboration with him in the Electric Motor Systems Annex, the IEA Technical Cooperation Program, and also in the earlier Motor Challenge Program. He also works on UNIDO programs all over the world. I welcome Konstantin. He'll talk about energy and other effects of digitalization in electric motor-driven systems. You have the floor. Konstantin.
Good afternoon, everyone. First, let me introduce myself. My name is Konstantin, and I'm working at the Austrian Energy Agency in the field of energy efficiency in commerce and industry. So today, I'm going to talk to you about the preliminary results of Task 3 of the Electric Motor System Annex, which is dealing with the effects of digitalization in electric motor-driven systems. Firstly, I want to give you some insights in the background of the project. Secondly, I'll describe two outcomes, the categorization of digital technologies and the EMSA survey. The Electric Motor System Annex is part of the Technical Cooperation Program 4E on energy efficient end-use equipment within the IEA. The target is to share information and support good policy development for energy efficient equipment. The goal of the Annex Electric Motor Systems is to raise awareness on the large savings potential in motor-driven systems while showing the realization method of such a path. The different tasks deal currently with digitalization in motor-driven systems, international standards and testing, tools and outreach. Participating countries are Australia, Austria, Denmark, the European Commission, Netherlands, New Zealand, Sweden and the US. Konrad Brunner founded the Annex in 2008. I personally have been working on this Annex since then. So what is the target of our task on digitalization? We want to categorize digital technologies in the field of motor-driven systems and quantify the effects on energy consumption. We want to identify areas of interest with high energy implications and collect policy programs and industry implementations or use cases in the area mentioned. Furthermore, we want to conduct a survey on advantages, disadvantages, enablers and barriers of using digital technologies. And finally, identify policy recommendations for further exploitation of the benefits of digitalization. When you deal with digitalization, you notice that this term covers a lot of different technologies. On this slide, you see which technologies we decided to focus on. Beginning on the left-hand side, there are smart sensors and advanced control on the level of machines and Internet of Things, enabling the communication between the different levels of and components. Furthermore, we will have a closer look on the possibilities to analyze data and therefore optimize the operation, data analytics on both the level of motor systems but also on the level of production lines or even whole companies. Also relevant, continuous monitoring of the different appliances. Technologies adding advantages to these applications are digital twins, cloud-based services and artificial intelligence. Augmented reality can help to implement the suggested measures. Three technologies that are not directly related to the optimization of motor-driven systems but of further interest are drones, 3D printing and advanced robotics. For each of these technologies we elaborate definition, description, applications for motor-driven systems, and try to find out energy effects. As first example, a sensor measures a physical, biological or chemical parameter and converts it into an electrical signal, which is sent to an electrical instrument where the measured parameter can be read. In industry, sensors measure, for example, temperature, vibration, pressure, volume, position and acceleration. In an interesting study on the impact of ICT, the current stock of sensors in industrial motor-driven systems is estimated to be at 50 million pieces in Europe, with 150 million additional sensors to be installed by 2030. These sensors would bring potential savings in electricity use of 5 to 10% in motor-driven systems, meaning 50 to 100 terawatt hours per year. Furthermore, there will be savings on maintenance costs, production costs and production improvement. As to the second example, data analytics generally deals with turning a great volume of data into actions and insights within a manufacturing system. Data analytics consists of several steps. For me important, this technology is, or at least should be able to deal with a lot of different data sources, e.g. nameplate data, but also data from control system or process data. Further steps involved are the data transfer and storage, data cleaning and data analysis with the main data mining methods, statistics and machine learning algorithms. Data analytics analysis efficiency information and load characteristics, forecast future conditions based on a machine's historical working patterns, or analysis and displays measured data against known bump performance curves. As to specific examples, I want to mention condition monitoring, measuring, for example, current and voltage from the motor control cabinet, and the detection of equipment faults by self-learning artificial intelligence algorithm. As effects can be mentioned, increasing uptime, energy efficiency and overall equipment effectiveness. In the last part of my talk, I want to discuss the results of the survey that we prepared on digitalization in electric motor-driven systems. It was sent out in different newsletters in Austria, Switzerland and Netherlands, furthermore in the international EMSA newsflash and via Twitter e.g. by the European Commission. 68 respondents filled out the survey. It closed on 20th of October. First, some characteristics of the organizations that answered the survey. Half of the organization were small companies, 1/3 of the companies were big ones. Around 1/3 are manufacturing companies, around 1/3 carry out scientific or technical activities. Almost 3/4 of the companies have a strategy to get more digitalized. 2/3 plan to invest in digital technologies within the next 2 years. This graph shows that while 1/4 of companies assess the savings associated with the use of digital solutions to be between 6 and 10%, half of the respondents estimate the increase of energy efficiency to be even higher at between 11 and 40%. This is quite impressive for me. From the technologies mentioned, more than half of the companies use smart sensors, advanced control and continuous state monitoring. Furthermore, data analytics on production lines and cloud-based services are adopted by more than 40% of the companies. In connection with motor-driven systems, the percentage is lower by around 7 to 10% lower. 3/4 of the respondents think that smart sensors and meters will help to save energy. Around 60% believe that advanced control and continuous state monitoring will lead to energy savings. IoT and data analytics are also considered as important drivers for energy efficiency. With respect to specific examples of motor-driven systems where digital technologies are already used, especially motors, controls, pumps and fans were mentioned. For these applications, smart sensors and smart control are particularly relevant according to the interviewees. Furthermore, IoT, condition monitoring and data analytics are relevant. As to advantages of using digital production technologies, the most important ones mentioned were superior production efficiency, higher system availability through predictive maintenance, and higher flexibility. In contrast, increased risk of failure and higher acquisition and implementation costs for infrastructure were cited as the main disadvantages. Around 70% of the respondents consider affordable key technologies and strict legislation to increase data and IT security as the most vital enablers for using digital production technologies. Relevance is also accorded to good technical solution for cybersecurity and involvement of employees. Major barriers specified are lack of qualified staff, high investment costs, and complexity relating to the integration into existing systems. Around 2/3 of the respondents consider standardization process for harmonizing protocols, the development of education programs and subsidies for research as important policy instruments to overcome these barriers. Finally, I want to invite you to inform us on any application you have where digital technologies are used primarily to increase the energy efficiency in motor-driven systems. On this slide, you see the persons involved in the annex. Here are the references of this presentation. At this point, I also want to thank especially the team of the Motor Summit for the possibility to present the first results of our tasks. And we are planning to publish all results and especially the results of the survey during the next month. Now, thank you very much. I'm looking forward to your questions.
Thank you very much, Konstantin. Interesting presentation, interesting new findings. So far, the term with the digitalization was sort of an abstract term. Welcome, Konstantin. I see you working from home. Can you hear me?
Yeah.
Can you hear me?
This is correct, but yeah. Hello?
Yes?
Yes, I can hear you.
But
can you hear me? There's quite a big delay, I think.
You have a big delay from Vienna to Switzerland. I don't see your mouth moving, but I see you shaking your head.
Yeah, I think I'm quite, the picture is quite behind. But anyhow, we can start.
Okay, I ask you some questions. Well, as I have understood, your expose on digitalization is that with the help of sensors, controls, smart monitoring, every motor becomes a persona. It has a name, an email address. The motor sends data to a center and receives orders from a control. Is this the future of digitalization of electric motor-driven systems?
Yeah, I'm a little bit confused with the picture because it's, I think, 5 minutes ago. But anyhow, yeah, but this is probably what you mentioned is I think definitely the future, but it will take some time and effort and resources of the of everyone involved in industrial technologies in industry. So it's not. I think Preston made a good point, and because he said, and I think this is also a little bit probably your opinion, that energy efficiency does not happen automatically in electric motor systems, and digitalization is a tool that can help, but we have to use it for this purpose, and there are definitely some barriers.
Yeah, interesting, very interesting. We still have the delay, but I think we can hear you sound and we can discuss, and you hear me, and there's no delay in the sound. Now, one customer, one participant was asking whether you have already developed something like a standardized method for estimating the savings from digitalization. Is there a method to calculate that?
No, I'm thinking of that, but unfortunately, it's not that easy. The first thing I have to say, because I in the meantime, after that I hold the presentation, I tried to find out the use cases we asked within the survey, and unfortunately there were not many, I have to say. So the first thing would to find really at least some use cases where digitalization was implemented and it triggered some savings, at least on the industrial side. And even this is not that easy as at least I thought at the beginning. But yeah, I mean, I can mention one example I saw recently in a company where electricity and compressed air was metered and displayed at production line level. And the person responsible for the production line had specific energy consumption targets he had to reach. And e.g. for the weekend, he had to shut down the appliances and machines until this level was reached. And so for this company I'm in contact with, and I hope that the energy savings will be just calculated more or less against the baseline of a usual, as the consumption during a weekend, which is now,
So you seem to believe that digitization avoids the use of energy, correct?
It should be the purpose. Yeah, I mean, if you use it for that, this is the main point. I think that's why I think political climate targets will lead industry to use digital for this purpose.
It's interesting to see when you move your lips and it's not in sync with the text, but I think we can manage somehow.
Exactly. Yeah, no, this is, I think, 3 or 4 minutes ago.
Okay.
Yeah.
That means we are already in present times and you're in past times. Now, but you said the goal is not just energy savings. The goal must be also to operate a factory on purpose, to produce quality products and to produce them fast and on time. Therefore, the effort, because you didn't mention the effort for digitalization. Digitalization, these sensors and these controls and the smart monitoring is an additional effort. It's cost and it's installation. Therefore, the benefit has to be clearly attributed either to the product or to energy.
Yeah, I'm not sure if I got your point correctly, but at least to my experience, the main purpose so far is on the one hand maintenance, and this is also corresponding to the result of the survey, so availability, but also I think transparency, mainly for cost accounting topics. And but if we want to save energy, we have to use digitalization for energy efficiency. But so far, the main target as Preston said, to predict failure or monitor the health of the equipment.
Okay, I got it. Now you made an important point, which I missed before. That means digitalization can avoid machines not working or not performing, and it can reduce maintenance. That's a good point. Now, I see a new question. Industrial plants have used local area networks, LAN, for monitoring, control, human-machine interface, production optimization, etc. for decades. What substantial, this is the question, what substantial change will IIoT make?
That's not that easy, but it's correct that, I mean, digitalization and Industry 4.0 are here for at least 10 years. But I think there are some trends like the price of sensors, the price of calculation tools, the knowledge on artificial intelligence, and the broader application of these technologies even in households. And I think that's why it will be sooner or later be also implemented in industrial area.
Okay. Thank you, Konstantin. Thank you for the interesting answers. Sorry that we had some audio problem or video problem. We'll improve. We work on that. Thank you for your contribution, and we'll see you next time soon. Thank you, Konstantin.
Yeah, thank you, Konrad. It was a pleasure for me.